In this second part of the video, we're going to look at the conditions that must be present for Bernoulli theory to work. And we're going to also work out a few more examples with you. So first off, on your companion sheet, I'd like you to note the conditions that must be present. First off, there have to be exactly two possible outcomes, one considered success and one considered failure. And success could be something like making a basket, it could be something like getting a tail when you flip a coin, it could be having a day of snow as opposed to no snow. There needs to be a fixed number of trials, which we're going to refer to as n. The trials have to be independent. In other words, when you flip a coin, you get a head, flip the next coin, it doesn't matter whether you got a head on the previous toss or not. It's still 50% probability of getting the next head. Finally, the probability of each outcome is the same for each trial. So if the probability of getting a success is p, so in other words, my probability of making a foul shot is 80%, then the probability of failing, q, is 1 minus p, so 20%, whatever's left. So on the back side, I'd like you to write the conclusion. For a given experiment, if the probability of successes is p, the probability of failure is 1 minus p equals q, then what's the probability of getting exactly r successes in n independent trials? Kind of think through this. We know we're going to have a c, right? N, C, R. N is the number of trials. R is how many I want to have happen, like how many heads I want or how many snow days. Then I need two probabilities. Think about what those are. They're p and they're q. So p's exponent is how many I want there to be. I wanted r successes, and p is the probability of success. Q's exponent is what's left, the number of total minus the r. All right, let's consider some examples here. A basketball example. LeBron James is about a 75% free throw shooter. And I want to find the probability he gets fouled on a three-point attempt. He has 3 foul shots. What's the probability he's going to make 2 out of 3? Okay, so let's start by identifying all the facts that we know. What's the number of trials? What's the number of successes? What is the probability of success? What's the probability of not being successful? Okay, so he's going to shoot 3 shots. He's going to make 2. Again, if you mix those up, it's going to come out 0. It just won't work. Then I need some probabilities. So 0.25 is the probability of failure. I want one of those. 0.75 is the probability of being successful. I want 2 of those. So 2 makes, 1 miss. They have to add up to 3. Label this thing. Probability of failure, probability of success. And then you might want to even label these exponents. Number of failures, number of successes. Then just work that out. Pop that in your calculator. Works out to be 2764, or about 42.19%. Next example. Consider a fair coin. Again, like we had before. We'll toss it 5 times this time. And I want to get exactly 4 heads. So one more time, I want you to think through, how many trials do we have? How many successes do I want? Next, what's the probability of being successful? It doesn't explicitly state it here, so you have to infer. Well, it's a fair coin. It's a 50-50 chance. Okay? So we've got 5C4. 5 tosses, 4 successes. Where success means get ahead. Probability of getting ahead is half. And I want 4 of them. Probability of getting a tail is half. I only want 1 of them, because they have to add up to the 5 times I toss the coin. Pop that in your calculator. Works out to be about 15.63%. We have a certain machine that makes parts, and because it's not perfect, 10% of them on average come out defective. So if I grab 10 of these parts, what's the probability that 3 of them will be defective? Okay, this is a good business question. Are you interested in this? Well, first off, what's our number of trials? And what's our number of successes? Well, in this case, being successful is weird. We want to count how many are defective, so being successful means it's defective. So it would be a 10C3. Next, I want the probability of being defective. So that would be a 1/10, 10%. How many of those do I want? What's my exponent supposed to be? 3. All right, what's left? If 10% are defective, 90% or 9/10 are defective. Or not defective, they're fine. And then what should the exponent be? Remember, the exponents have to add up to how many we have total. So it's 7. Calculator, 5.74%. All right, in this next question, number 4 and number 5, we're making it just a little bit more complicated. Notice the key word is at least in this problem. Key phrase. All right, so let's assume over the course of a season, the Yankees win about 2/3 of their games. So they've got a 4-game series. Assuming that probability holds, what is the probability that they're going to win at least 3, not exactly 3, but at least 3 out of those next 4 games? So you have to interpret what that means. If they win at least 3 games, basically what it's saying is they win 3 out of 4, or they win 4 out of 4. So really, we've just made this into 2 mini problems that we're going to compute probabilities of each one. Now think about the word or. What are we going to do with those probabilities once we have each of them computed? Remember back to our initial study with rolling a die, getting a 6, or getting a coin to be ahead. If it's an or situation, it increases our probability, our likelihood of success. So we're going to add those 2 probabilities. So let's work out each part individually. First, we've got 3 out of 4, so that would be a 4C3, right? We want 4 wins. 3 wins out of the 4. Your probability of a win is 2/3. How many wins do we want? We want 3. Probability of a loss is 1/3. Well, then there's only going to be one of those, right? So it's 4C3, 2/3 to the third, 1/3 to the 1. Plus, I want you to fill in this right side and then play the recording when you think you've got it. Okay, so hopefully you had 4C4, number of wins. The probability is still the same. 2/3 is a win. And I want 4 of them, right? I want to win all of them. So 1/3 is a loss. Think about, well, what's the amount of losses that we could have? 0, right? So you're just going to put this in your calculator, get a percentage, put this in your calculator, get a percentage, and then add up those 2 probabilities. (59.26%). Last question we're going to consider is an interesting one. All right, think about any family that you know that has 5 children. Okay, maybe you know a family that doesn't matter if they're grown people or they're young kids or whatever. Think of a family you know that has 5 children. I'm interested if they have at most 2 boys. Okay, I want you to think about what that means to be at most 2. How many boys can they have if they have at most 2? So I want you to consider that for a second. If they have at most 2 boys, that must mean they have 0 boys, or 1 boy, or 2 boys. And we're going to make the assumption that the probability of a baby being born, boy or girl, is exactly 50%. Okay? So what I want you to do is I want you to figure out each individual probability, getting 0 boys out of 5, 1 boy out of 5, 2 boys out of 5. Add those up, come up up with your final answer and round it off to the nearest whole number. Then you're going to put that answer into Edmodo, and that will be your homework. Thanks for watching.